Meow, meow, meow. Huh? My energy life is at its minimum level. Food needed! Food needed! Food needed! Meow, meow, meow. Wow! What a strange world! I have been transported into the world of electricity. Wow! Well, at least my energy level is back to normal. That means that I, Titan, can show you around and explain what electricity is. Matter is made up of invisible particles called atoms. Each atom has negatively charged electrons. They orbit around a nucleus which is made up of positively charged particles called protons and neutral particles called neutrons. When an atom has an equal number of electrons and protons, it is in a normal state. This means that it is electrically balanced or uncharged. But when an atom is in an electrified state, its electrical balance is disturbed. This happens when some electrons are removed from the orbit or added to it. When this occurs, the atom is ionized. If we charge two objects by friction, some electrons from the surface atoms of one object are transferred to the other object. Cannot be created, or destroyed during friction. It can only be transferred from one object to another. Yeah. Wow, that was really crazy. During friction, due to rubbing, the nature of the object's surfaces are changed. The objects are said to be charged or electrified. This is known as electrostatics. Some electrons from the surfaces of the plastic ruler are transferred to the cloth. This makes the ruler positively charged because it has lost some electrons. The cloth, however, becomes negatively charged as it has gained some electrons, and the effect is that the plastic ruler is able to attract light objects when it is charged. There are two kinds of charges produced by friction. Like charges always repel each other, and unlike charges always attract each other. Ta-da! Do you know what this bulky thing is? I know. Oh yes, now I remember. It's a telescope. No, wait. It's an electroscope. The electroscope is made up of a brass cap, an insulator, an earth metal case with a glass window, a brass rod, a gold leaf, and a brass plate. The brass cap, brass rod, brass plate, and the gold leaf are electrically neutral. This means that there is no excess charge. When a charged object, say a positively charged glass rod, is placed near the brass cap, free electrons from the brass and gold parts of the electroscope are attracted to the brass cap. This results in the brass plate and gold leaf being positively charged, and the gold leaf will diverge. So, this is how electrostatic works. But how is it related to our everyday life? Well, the thunderstorm is an example. Usually, flashes of lightning can be seen before and during thunderstorms. This is caused by the large amount of electrical charges built up in the thunderclouds. The thunderclouds are charged due to the friction between water molecules in them and the surrounding air molecules. When the charge on the thunderclouds gets large enough, it ionizes the air. The ionized air creates a conducting path for the large amount of charges to be discharged in the form of lightning to the nearest or sharpest object on the ground. Wow! Too many electrical charges produced by friction may also cause fires and explosions. Soldiers who build trenches in hilly areas should not use zinc sheets as shelter from thunderstorms. Do not swim in the open sea, play in an open field, or hide under a tree during a thunderstorm. Use lightning conductors on tall buildings to prevent damage by lightning. The conductor becomes a discharge path for the electrons to flow from the top of the building down to the earth. Electricity is a form of energy that can be changed to many other forms, so it has many uses. to make electrons move in one direction through a conductor to produce electricity for everyday use. Ouch! Hey! Ouch! 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 One source of electricity is the battery. In its cells, electricity is produced through chemical reactions. Solar cells are another source of electricity. They convert light energy from the sun into electrical energy. Electric charges are made up of either positive charges, such as protons and positive ions, or negative charges, such as electrons and negative ions. When these electrical charges flow, they produce a current. An electrical current is the rate of flow of electric charges. The unit for measuring electric current is the ampere. So, a current of 1 ampere is the rate of flow of a charge at 1 coulomb per second. This is the movement of free electrons in a conductor, and this is the flow of electrons through a conductor forming electricity. There is another device that I want to tell you about besides the electroscope that I just threw away. It's called the Van de Graaff generator. This device is a high voltage electrostatic generator which is able to produce a potential difference of millions of volts. It is used to create static electricity for use in experiments. The Van de Graaff generator is made up of a motor, 2 rollers, a belt, 2 brush assemblies, and an output terminal, which is usually a metal or aluminum sphere. When the generator is switched on, positive charges from the output terminal attract electrons from the earth through the water pipe. This flow of electrons causes the pointer on the galvanometer to move, indicating that electricity is present. I see. But what about voltage and resistance? Well, voltage is the difference in electrical energy between any 2 points in a circuit. Resistance means how much an electrical component restricts the flow of current. We use the ohm to measure resistance. I wonder where this hole leads to. Wow! Do you know what this is? It's a gigantic ammeter. Wow! An ammeter is a thing that we use to measure electric currents. It has to be connected in a series in order for it to work well. We start from the switch to the ammeter, to the bulb, and then to the battery. This makes the current flow into the ammeter by the positive terminal and leave by the negative terminal. Ooh, there is another device over there. Let's take a look. It's quite different from the other one we just saw. This is called the voltmeter. A voltmeter is the device used to measure the electromotive force of an electric source. The voltmeter has to be connected in parallel. This is because electrical charges in a circuit will flow from a point of higher electrical potential to a lower one. The positive terminal of the cell must also be connected to the positive terminal of the voltmeter, while the negative terminal of the cell must be connected to the negative one. There's another thing that we need to know about measuring the current and voltage. I indicates the flow of current in a circuit, and the ammeter will show us the amount. The voltmeter will show us the potential difference across the resistor R. Let's look at what we have learned today. Matter is made up of invisible particles called atoms. Each atom has negatively charged electrons. They orbit around a nucleus which is made up of positively charged particles called protons and neutral particles called neutrons. The electroscope is made up of a brass cap, an insulator, an earth metal case with a glass window, a brass rod, a gold leaf, and a brass plate. The Van de Graaff generator is made up of a motor, 2 rollers, a belt, 2 brush assemblies, and an output terminal, which is usually a metal or aluminum sphere. When the generator is switched on, positive charges from the output terminal attract electrons from the earth through the water pipe. This flow of electrons causes the pointer on the galvanometer to move, indicating that electricity is present. Do you know what this is? It's a gigantic ammeter. This is called the voltmeter. Ooh, a comic book, my favorite!